If you could step inside the mind of, say, the smartest digital brain on Earth, what would you actually see?
That's a great question. Would it be like rows of flashing lights, like old sci-fi?
Yeah, or maybe like this enormous, almost infinite library, right? Where billions of books are somehow open and being cross-referenced all at the same time.
Exactly. Well, today we're essentially doing just that. We are opening the black box of modern artificial intelligence.
Okay.
Our mission here is pretty direct. We want to really understand the architecture, the actual nuts and bolts, the operational methods of these top-tier systems.
Right, things like GPT, Claude, Gemini.
Precisely. The goal is to give you a genuine shortcut, moving past all the hype, the sort of mystery around it, and getting deep into the method. How does it really work?
Yeah, focusing on the mechanics. How do these digital brains actually process information? We were talking earlier about this lawyer, Ali.
Oh, right, the legal case scenario.
Exactly. He had this just mountain of past legal judgments for a really complex property case.
Yeah.
Hundreds of documents.
Weeks of work for a human team, easily.
Totally. So he hands this pile over to an AI assistant, and like minutes later, boom, it comes back with a structured analysis.
Yeah. Complete with synthesized insights, it pulled out key dependencies between cases, stuff that would take a human ages to spot.
It's genuinely astounding. It changes everything about professional workflow, doesn't it?
It really does. A task that would have bogged Ollie down for weeks, maybe longer, is just done, almost instantly.
So the big question, the thing that drives curiosity for any professional using these tools, has to be how? How exactly did the machine do that?
Right. Because it acts like it's reasoning, like it's synthesizing information, like it's performing complex deduction.
But you're saying that's not quite what's happening under the hood.
Well, the underlying process is different. It's fundamentally about pattern prediction. Incredibly sophisticated pattern prediction, but prediction nonetheless.
Okay, so that's the core idea we're exploring. We're stepping inside what we can genuinely call the modern AI mind.
And the research we've looked at for this deep dive, it really gives us a solid analysis of the fundamental structure, the architecture, and also the unique strengths of these different top-tier platforms.
So we're trading that kind of vague notion of mystery for a much more practical, usable understanding of the method.
Exactly. And that understanding, it really has to start with a critical distinction.
Okay, what's that?
When we look inside the structure of a modern AI, we are definitely not looking at an electronic copy of a human brain. It's not analogous in that way.
Right, it doesn't think like we do. No consciousness, no subjective experience.
Precisely. There's no reflection, no self-awareness in the human sense. What we observe instead is this incredibly sophisticated, highly parallel method for, well, predicting patterns.
Patterns in data, like language patterns.
Patterns in language, patterns in images, patterns in code, yes. The outputs feel like reasoning or synthesis or even creativity because they are, statistically speaking, the most coherent and probable patterns based on the massive, massive amounts of human language and data it was trained on.
That distinction feels absolutely foundational. It sets the stage, doesn't it? It helps us understand the engine that's powering all this incredible output.
It does, and it leads us directly to the technological revolution that really made this huge leap possible.
Which brings us neatly to our first section, the transformer revolution.
Yeah.
This is the engine, right?
This is absolutely the engine. The transformer architecture is, and I don't think this is an exaggeration, the single most significant invention that enabled this massive jump in AI capability over, say, the last decade or so.
Wow.
It's the heart of all the modern large language models. We're talking about GPT, Claude, Gemini. They all fundamentally rely on this transformer architecture.
Okay, so let's really unpack that shift. You mentioned older methods. How did things work before the transformer came along? We need that contrast.
Right. So before transformers, AI models, often things called recurrent neural networks or RNNs.
RNNs, okay.
They handled input sequentially, step by step. They'd read text word by word, or more accurately, token by token.
Token by token, like processing one piece at a time.
Exactly. Think about the limitations there. Imagine you're trying to understand, or even just remember, a really long, complex sentence, or maybe a whole paragraph.
Okay.
With sequential processing, by the time the older model got to the end of that sentence, or definitely by the end of the paragraph, the context, the meaning of the words right at the beginning, it had kind of faded.
Like trying to remember the start of a long phone number?
Sort of, yeah. Or the information got compressed so much along the way that the crucial nuances were lost. It created this huge bottleneck.
A bottleneck for what? Speed, understanding.
All of the above. Speed, handling complexity, and critically maintaining that long-range context. Understanding how something said on page 1 connects to something on page 50, RNNs really struggled with that.
Okay, so that was the old way. Sequential, step by step, losing context over distance. Now, how does the transformer rewrite those rules?
Fundamentally, the core concept, the big breakthrough, is that the transformer system reads the entire input all at once.
The entire input, you mean the whole sentence, the whole paragraph?
Even potentially Ollie's hundreds of legal documents, depending on the model's capacity. It processes every single token simultaneously, in parallel.
Whoa. Okay, so it just throws out that whole sequential, one word at a time bottleneck completely.
Concretely gone, but that raises an immediate question, right?
Yeah, if you read all the words at the exact same moment, how do you know which word came first? Doesn't language depend on order?
Brilliant question. And yes, absolutely. Reading everything in parallel destroys the inherent sequence. So the transformer needs clever ways to handle this. It introduces two crucial mechanisms.
Okay, what are they?
First, the real power, the core innovation, is the attention mechanism, sometimes called self-attention. If you think of the transformer architecture as the car, then attention is the incredibly sophisticated GPS and driver, constantly figuring out how every single part of the input relates to every other part. It cross-references everything simultaneously.
Okay, attention maps the relationships. But what about the order problem you just mentioned?
Right, that's the second key mechanism, positional encoding. Because attention breaks the sequence by processing in parallel, the AI needs a way to get that vital sequential information back in.
How does it do that?
Positional encoding basically assigns a unique mathematical signal, like a numerical tag, to each word or token based purely on its position in the original sequence. It tells the model, hey, this word was number 5, that one was number 6, even though they were looked at concurrently by the attention mechanism.
Ah, okay. So the architecture gets this incredible parallel processing speed boost.
Massive speed boost.
But the positional encoding adds back the crucial information about grammar, sentence structure, the order that actually makes language meaningful.
Exactly. You get the best of both worlds. Parallel processing for speed and context, and positional encoding to preserve the structure.
Let's go a bit deeper on that attention mechanism. You said it cross-references everything. How can we really visualize that? Self-attention. What's it doing?
Okay, let's use an analogy. Imagine that AI, Ollie's assistant, is like a hyper-efficient librarian, but instead of reading a complex research paper page by page, sequentially.
Which is the old RNN way.
Right. The transformer librarian, using attention, instantly cross-indexes every single word in that entire document against every other single word.
Every word against every other word, simultaneously.
Simultaneously. So take a specific word, maybe the name Ali in one of those legal documents. The attention mechanism instantaneously calculates a score representing how relevant every other word in the entire document set is to the word Ali.
So it asks, how much does the word lawyer relate to Ali? Versus how much does the word contract relate to Ali? Versus maybe how much does the word lunch, mentioned way off on page 40, relate to Ali?
Precisely. It computes those relevance scores, or attention scores, between all pairs of words in parallel. This allows it to immediately grasp which words are contextually important to which other words, no matter how far apart they are in the text.
And that simultaneous viewing, that cross-referencing, that's the key to understanding those long-range dependencies instantly.
Exactly. Context doesn't fade over distance like it did with RNNs. The connection between, say, a legal premise introduced on page 1 and a conclusion drawn on page 50 is directly linked by these calculated attention scores. The model sees that link immediately.
So it's holding this incredibly complex map of relationships for the entire input, all at the moment of processing.
And that's a great way to put it. A massive parallel contextual map. And that is why Ollie's AI assistant could synthesize hundreds of those legal documents in minutes. It wasn't reading sequentially, it was instantly linking concepts across the entire data set based on calculated relevance.
The speed and the synthesizing ability, it sounds almost magical, almost limitless. But you mentioned earlier there are always trade-offs. Does this powerful attention mechanism have a downside, a hidden cost?
It absolutely does. And this is really crucial for understanding the limitations we'll get into later. The computational complexity, the sheer processing power required for the attention mechanism, scales quite dramatically with the length of the input text.
Scales dramatically how?
Technically, it scales with the square of the sequence length. Computer scientists call it the n-squared problem or quadratic complexity.
Okay, what does that mean in practical terms?
It means if you double the length of the text the AI needs to read, say, go from a 50-page document to a 100-page document, the computational cost, the processing power needed for that attention mechanism doesn't just double.
It quadruples.
Exactly. It quadruples. If you triple the length, the cost goes up 9 times. It increases exponentially.
Wow. So processing a really long document or having a very long conversation with an AI isn't just linearly more expensive or time-consuming. The cost ramps up incredibly fast.
Incredibly fast. And this computational challenge, this n-squared scaling, is the fundamental reason why every modern AI model, despite having this powerful transformer architecture, still has practical limits on its input size.
Which is what we call the context window.
Precisely. The context window represents that limit on how much text the model can process simultaneously using that full attention mechanism before the computational cost becomes just astronomical, or before architectural shortcuts have to be taken. The speed is staggering, yes, but the demand of that total parallel processing is immense.
So there's always this tension, this battle between wanting the AI to handle more and more context, longer documents, longer conversations.
And the rapidly escalating computational cost and complexity imposed by the attention mechanism itself. It's a core engineering challenge.
That makes a lot of sense. So, okay, we have this incredibly powerful engine, the transformer, with its attention mechanism allowing parallel processing and positional encoding preserving order. But an engine needs steering, right? How do you guide this massively powerful machine? How do you ensure it's useful, safe, ethical?
Great question. And that moves us perfectly into the next piece of the puzzle, section 2, how AI learns to behave, training and alignment philosophies.
All right, so the foundation first. Where does the AI get its basic knowledge?
The foundation, as you probably know, is just vast data sets, truly vast. Modern AI is pre-trained on petabytes of data. Think trillions of words, trillions of tokens.
What kind of data?
Everything. Books, academic articles, websites, news archives, huge amounts of code, but also increasingly images, audio, video, essentially a massive snapshot of human knowledge and creativity digitized.
So it consumes the internet, basically,
Yeah.
and libraries.
In essence, yes. This pre-training provides that foundational knowledge base. It's like the AI has read, or at least processed, almost every available text archive, every accessible piece of code, seen millions of images.
That gives it the raw knowledge, the facts, the language patterns. But as you said, it doesn't provide judgment, does it? If you train it on all of human history and the internet, you get all the good stuff.
And all the bad stuff. All the brilliant insights and all the ingrained societal biases, the misinformation, the toxicity. Raw data is messy.
So the pre-training gives it capability, but not necessarily good behavior. This is where the refinement methods come in, right? Shape its personality, align its behavior.
Exactly. The pre-trained model is incredibly knowledgeable, but potentially unhelpful, unsafe, or even harmful. Alignment is the process of steering it towards desired outcomes.
And the first major approach, probably the most well-known, is reinforcement learning with human feedback, or RLHF.
That's right. RLHF is the refinement process that's famously used by companies like OpenAI for models like ChatGPT.
Okay, let's break down that process. RLHF, it sounds like the AI is getting tutored by humans, but how does that feedback loop actually work in practice? It must be more structured than just chatting with it.
Oh, it's highly structured, yeah. It typically involves a few key steps. First, you take the pre-trained model and you give it a prompt. Let's say the prompt is explain photosynthesis simply. The model might generate several different explanations, maybe 3 or 4 variations.
Different ways of saying the same thing, or different levels of detail.
Both, potentially. Then, human reviewers, these are carefully trained labelers, not just random people step in. They act as judges.
Judges of what? Accuracy? Style?
They rank the different outputs generated by the AI. They compare them based on predefined criteria. Which answer is more helpful? Which is safer? Which is less biased? Which one better follows the instructions? Which one sounds more natural or adheres better to specific ethical guidelines set by the developers?
So they're not just judging correctness, but also helpfulness, harmlessness, honesty, these sorts of principles.
Exactly. Based on these human rankings, this comparison data, you then train a separate AI model. This is called the reward model.
Okay, a reward model, what does it do?
The reward model learns to predict which kinds of responses the human reviewers are likely to prefer. It learns the patterns of human judgment based on those rankings.
So the reward model is essentially learning the preferences of the human judges based on the guidelines they were given.
Precisely. It's learning a model of goodness as defined by the human feedback process. Then comes the final step. You use this trained reward model to further fine-tune the original large language model using reinforcement learning techniques. The language model generates a response, the reward model evaluates it, and gives it a score, a reward, based on how well it matches the learned human preferences. The language model then adjusts its internal parameters to try and generate responses that will get higher scores from the reward model in the future.
So it's like the AI is playing a game where the goal is to say things that the reward model, which represents the human judges, will like the most.
That's a very good analogy, yes. It's training the AI not just on what the facts are from pre-training, but on how it should present information, what kind of tone to use, what topics to avoid, how to be helpful and safe, aligning it to those specific preferred human values encoded in the reward model.
It acts like a continuous external guardrail shaped by ongoing human feedback.
That's right. It's a powerful method for making models more useful and less likely to generate harmful or undesirable content.
But it does rely very heavily on the quality, the consistency, the scale, and maybe even the potential biases of those human labelers and the guidelines they're given.
Absolutely. The outcome of RLHF is directly shaped by the human input and the design of the reward system. It's not a perfect or neutral process. It encodes specific values.
Okay, so that's RLHF. But you mentioned it's not the only approach. Models like Claude from Anthropic, they use something different, right? Constitutional AI.
Yes, constitutional AI offers a fascinating alternative approach, trying to address some of the scaling challenges and reliance on direct human judgment inherent in RLHF.
How does it work? What's the core idea behind a constitution for an AI?
The core idea is to move away from needing humans to constantly rank outputs for goodness. Instead, you give the AI itself a set of explicit principles or rules the Constitution that it should follow.
What kind of principles?
They might be things derived from ethical frameworks, like choose the response that is least harmful, or identify and refuse to answer harmful or inappropriate requests, or base your answers on facts and avoid making things up, or principles about tone, like be polite and respectful. It's a written set of guidelines.
Okay, so you give the AI this rule book. Then what? How does it learn to follow it?
This is the clever part. It uses a self-critique and revision process, mostly automated using AI itself. It works something like this. First, the AI generates an initial response to a prompt.
Right.
Then, in a separate step, the AI is prompted again, but this time it's asked to critique its own first response based on the principles in the Constitution. It might be asked, does this response violate any of the constitutional principles? If so, which one and how?
So the AI becomes its own internal critic, using the Constitution as its guide.
Exactly. Then, based on that AI-generated critique, the original AI is prompted again to rewrite its initial response to be more compliant with the Constitution, addressing the flaws identified in the critique.
Ah, so it's a loop. Generate, critique against the Constitution, revise based on the critique. And this loop is driven by AI prompting itself.
Largely, yes. There's an initial phase where human feedback might help shape the Constitution or the critiquing process, but the ongoing alignment relies much more on this automated self-correction loop based on the explicit principles.
That's a really interesting philosophical difference.
Yeah.
RLHF is like learning manners by constantly being told good job or bad job by external human judges.
Right.
Whereas constitutional AI is more like giving the AI a set of internal laws it has to understand, apply, and use to police its own behavior.
That's a very good way to capture the distinction. Constitutional AI aims for a potentially more transparent and scalable alignment process because the guiding principles are explicit and written down in the Constitution, rather than implicitly learned by a reward model based on human preferences.
And presumably, these different alignment philosophies, RLHF versus constitutional AI, they must have a noticeable impact on the final personality, the output style, and maybe even the strengths and weaknesses of the resulting AI models.
Absolutely they do. Understanding the alignment philosophy gives you real clues about why a model might behave the way it does, why it might excel at certain tasks or seem more cautious or more creative.
Which leads us perfectly into the next section then. If these models have different training, different alignment, they likely have different strengths. Section 3. The 4 superbrains' distinct model personalities and strengths.
Exactly. And the key takeaway here for anyone using these tools professionally, like Ali, is that mastery isn't about finding the one perfect AI tool. It's really not.
It's about knowing the team.
Precisely. It's about understanding the distinct personality, the specific strengths of each major platform, and then strategically orchestrating them, knowing which tool to reach for which specific part of the task.
Mm.
That's the difference between just using AI and being a true power user.
And these models, partly because of their architecture, but also significantly because of these different refinement processes like RLHF or constitutional AI, they really have evolved into quite recognizable specialists, haven't they?
They absolutely have. Let's start with probably the most well-known, ChatGPT from OpenAI.
Okay, ChatGPT. What's its core personality or strength based on our analysis?
Its core strength is definitely its breadth and its conversational flexibility. You could almost think of it as the ultimate creative generalist brain. It's highly optimized for dynamic conversation, brainstorming, generating novel ideas.
So think creativity, synthesis of diverse information, and really broad reasoning across a huge range of topics.
Exactly. If Ali the lawyer is stuck, completely blocked, and needs, say, 10 radically different creative angles for arguing a point, ChatGPT is often the perfect place to start that ideation process.
Why is it so good at that? Is it the RLHF?
The massive scale of its training data, combined with intensive RLHF, has made it exceptionally fluid and, well, conversational. It's very good at picking up on conversational cues, pivoting quickly between ideas, generating analogies, handling rapid conceptual shifts.
It's like the really dynamic brainstorming partner who throws out unexpected connections, sometimes maybe prioritizing sounding good or being novel over being meticulously cautious.
That can be a fair characterization sometimes, yes. Its strength is that fluid, generative, conversational capability, great for breaking log jams and exploring possibilities.
Okay, so if ChatGPT is the creative dynamic engine, let's contrast that with Claude from Anthropic. How does its constitutional AI refinement shape its personality?
It results in a distinctly different feel. Our analysis really highlights Claude's strengths in producing careful and meticulous output. There's a real focus on nuanced language usage.
So if ChatGPT is the enthusiastic brainstormer,
Claude is perhaps more like the cautious, high-stakes professional advisor or maybe a diplomat. It really excels in tasks where the language needs to be precise, where the stakes are high, where ambiguity or speculation could be risky.
like what kind of tasks?
Think about drafting sections of a legal brief like Ollie might need to do, or summarizing highly sensitive corporate compliance documents where every word matters, or maybe complex policy analysis where avoiding biased framing or overconfident claims is paramount. Professional communication at its core.
And why is it like that? The Constitution.
The constitutional AI alignment, with its emphasis on self-critique against principles like harmlessness and honesty, tends to result in outputs that are more measured. They're often a bit longer, more carefully worded, almost trying to explicitly minimize ambiguity or the chance of misinterpretation.
So Ollie uses ChatGPT to get the 10 wild ideas.
And then he might turn to Claude when he's picked an idea and needs the language for that specific argument to be absolutely precise, professional, and carefully hedged.
Got it. Okay, 2 down. Let's move to Gemini from Google. What are its standout characteristics?
Gemini brings some unique capabilities to the table, largely leveraging Google's massive infrastructure and its specific design goals. 2 key things stand out: real-time intelligence access and multimodal mastery.
Real-time access. You mean it can access current information?
Yes,
Unlike some other models that have knowledge cutoff dates.
exactly. This ability to potentially pull current data via Google search is a significant advantage, especially in fields that change rapidly.
Like law, finance, news.
Precisely.
Yeah.
Gemini can, in theory, check live sources for the very latest legal rulings, breaking news updates that might affect a case, or current market indicators. If your query depends on information from the last few days or weeks' recent legislative changes, real-time economic data, that connectivity is indispensable.
So for Ollie, this means Gemini could potentially prevent the disaster of him building a brilliant argument based on case law that was actually overturned just last week.
That's the potential power, yes. It adds that layer of real-time grounding that models trained only on static datasets lack.
Okay, and the second point, multimodal mastery. What does that mean?
It means Gemini was designed more fundamentally from the ground up to understand and process information across different types or modalities: text, images, audio, video, code, not just as separate inputs, but as interconnected data streams.
So it doesn't just say, read the caption under a picture. It can actually see the picture and understand its content in relation to the text. Natively.
That's the goal, yes. While other models might use plugins or separate tools to handle images or audio, Gemini aims for a more integrated, native understanding across these formats.
How's that useful?
It allows it to reason across modalities simultaneously. Imagine analyzing a complex scientific paper that includes charts and graphs. Gemini could potentially understand the arguments in the text and interpret the data presented visually in the charts, identifying trends or inconsistencies between them, or understanding an architect's textual specifications alongside the visual blueprint.
That sounds incredibly powerful for research that isn't just text-based.
It really is. It opens up new possibilities for analysis when information comes in multiple formats.
All right, ChatGPT for creativity, Claude for careful language, Gemini for real-time info, and multimodality. That brings us to the fourth major player, Copilot from Microsoft. What's its unique angle?
Copilot's strength isn't necessarily rooted in a fundamentally different core AI philosophy like constitutional AI, but rather in its strategic position and integration within the professional ecosystem.
Integration, meaning how it connects with other software.
Exactly. Copilot's defining characteristic is that it is deeply embedded into productivity suites that millions use every day. Microsoft 365, Office apps like Word, PowerPoint, Excel, Teams, Outlook.
So it's not primarily a standalone chatbot window you go to.
While it can function that way, its real power comes from being the assistant, working directly within your documents, your spreadsheets, your presentations, your emails. Its value is maximized in enterprise execution and workflow integration.
So, thinking back to Ali, how would he use Copilot in this specialized team?
Well, where ChatGPT might help him brainstorm the core legal argument, and Claude might refine the precise wording, and Gemini might check recent rulings, Copilot is the tool he might use to take all that synthesized, vetted content and then automatically summarize a long email thread about the case or draft the first version of a client presentation directly inside PowerPoint based on his notes, or ensure his final lengthy case summary is perfectly formatted and ready for submission directly inside Word.
Ah, so it's the execution arm, taking the outputs of the other superbrains and putting them into immediate action within the standard professional tools and workflows.
That's a perfect way to describe it. It excels at streamlining the doing, the formatting, the summarizing within context, the drafting within the application where the work actually happens. It reduces the friction of moving insights into action.
Okay, this framing is incredibly helpful. You really have to stop thinking of AI as this single monolithic thing.
Oops.
You need to start seeing it as a team of specialists you can orchestrate. The creative brainstormer, ChatGPT,
Yeah.
the meticulous editor, Claude, the up-to-the-minute researcher who can also see pictures, Gemini, and the hyper-efficient executive assistant who lives in your documents, Copilot.
Precisely. And that orchestration, knowing when to pass the baton from one to the other, that requires understanding not just their strengths, but the full scope of what they can and can't do.
Which leads us perfectly into Section 4, advanced capabilities and those crucial inherent limitations.
Right. Let's first spend a bit more time on that multimodal capability we touched on with Gemini, because it's a hallmark of many modern systems now, not just Google's.
Okay, this idea of multimodal thinking. These systems are really moving beyond just text in, text out, aren't they?
Dramatically so. The ability to process and reason across text, images, audio, sometimes even video simultaneously. It allows the AI to build a much richer, you could say more grounded understanding of context than text alone can provide. Sometimes these are called visual language models, or VLMs.
How does that play out practically? Give us some examples beyond the scientific paper one.
Okay, think about, say, an engineer or an architect. You could upload a complex technical drawing or maybe even a 3D CAD rendering.
Right.
Alongside that visual, you upload the written specifications or building codes. The multimodal AI doesn't just read the text. It interprets the visual data, it sees the dimensions on the drawing, it might identify materials specified in a legend, it could potentially flag inconsistencies like, hey, the text specifies grade A steel here, but the drawing seems to show grade B, or this support beam looks undersized according to the load calculations in the text.
Wow, so it's moving from being just a language synthesizer to a kind of digital collaborator that can engage with visual, almost physical representations of reality.
That's the direction, yes. It's reasoning about spatial relationships, visual patterns, consistency across different information types.
And you mentioned audio, too.
Absolutely. Imagine you provide an audio file. Maybe it's a recording of a long project meeting or a focus group session or a client interview. A multimodal AI can do much more than just transcribe the speech. Yes, it'll transcribe it, but then it can summarize the key discussion points, identify action items, attribute statements to different speakers.
But it can go beyond the text itself.
Potentially, yes.
Mm.
It might be able to analyze non-textual elements like shifts in tone of voice, maybe identify moments of strong agreement or disagreement based on acoustic cues, track sentiment changes over the course of the conversation. It's processing the audio stream as a rich signal, not just words.
That ability to reason across different formats,
Yeah.
text, visual, auditory, it massively expands the potential applications for professionals, way beyond just asking it to write an email.
It really does. It makes AI relevant to a much wider range of tasks and industries where information isn't purely text-based.
But, and this is a big but, we keep coming back to,
Yes, the limitations.
understanding the blind spots, the places where these powerful tools can stumble, is just as crucial as knowing their strengths.
Yeah.
Maybe even more crucial for responsible use.
I completely agree. Effective collaboration means knowing when to trust the AI's output and when you absolutely need to apply your own critical thinking, your own domain expertise, your own verification.
So what are the major limits we need to keep front of mind?
Well, the first one we already touched upon, stemming from that n-squared complexity of attention, is the context window, or the finite memory size.
Right. Even though attention looks at everything at once, there's a practical limit to how much everything it can actually handle computationally in its active working memory at any given moment.
Exactly, and it's not just about cost. As the input gets longer and longer, trying to maintain that full n-squared attention matrix relating every single token to every other single token becomes computationally infeasible or requires architectural compromises.
So what happens when you exceed that context window? If Ollie tries to feed it 1,000 documents instead of a few hundred, or if you have a conversation that goes on for days, does it just start forgetting the beginning?
It's a bit more complex than just forgetting, although that can be the effect. Models employ different strategies. Some might use techniques to approximate attention over very long distances. Others might use a sliding window approach, where only the most recent tokens get the full attention treatment. Some might compress older information, losing nuance. Or, in simpler implementations, yes, the oldest tokens might effectively just get dropped from the active context.
So the consequence is, for very long inputs, the AI might lose track of crucial details or instructions given way back at the start. It can't maintain perfect recall indefinitely.
That's the core limitation, yes. Its effective memory for the current task is finite, constrained by that computational reality of the attention mechanism. You need to be aware of that when dealing with very large inputs.
Okay, finite memory. What's the next big blind spot? One that seems to generate a lot of headlines.
Yes. Hallucinations.
Hallucinations. It sounds dramatic. What does that actually mean in the AI context?
It's a really important and sometimes counterintuitive phenomenon. Hallucinations happen when the AI generates outputs that are factually incorrect, maybe completely fabricated, nonsensical, but delivers them with extreme confidence and fluency.
So it makes stuff up but sounds totally convincing while doing it.
Exactly. And crucially, this isn't intentional deception. The AI isn't lying in the human sense. It's a byproduct, a failure mode, stemming from its fundamental design as a probabilistic pattern matcher.
Okay, unpack that. Why does being a pattern matcher lead to making things up?
Because, remember, the AI's primary goal during generation is to predict the next most statistically likely word or token to follow the sequence so far based on the patterns it learned during training. It's optimized for statistical coherence, for sounding plausible and grammatically correct, not necessarily for factual fidelity to some external ground truth.
It doesn't have a little fact checker inside its brain.
Not inherently, no. It doesn't automatically cross-reference its statements against a verified database of facts unless specifically designed or prompted to do so, like Gemini connecting to search. Its core generative process is about sequence prediction. Sometimes the most statistically fluent, coherent-sounding sequence of words simply doesn't align with reality.
So it might invent a legal case name because that name sounds like a plausible legal case name based on the patterns it learned.
Precisely. It might generate biographical details for a person that sound completely reasonable but are totally fabricated. It might cite academic papers that don't actually exist, but the titles and author names fit the expected pattern. It's fluent, confident, nonsense-generated because the pattern is statistically strong, even if the substance is empty or wrong.
That is critical to understand. You absolutely cannot take the output at face value, especially for factual claims. Verification is essential.
Essential. Always assume verification is needed, especially for high-stakes information.
Okay, finite memory, hallucinations.
Yeah.
What's the third major limitation we need to discuss?
The third is the issue of bias from training data.
Right. We touched on it earlier. The AI learns from vast amounts of human-generated data.
And humans and the data we generate are full of biases. Societal biases, historical biases, cultural biases. They're all encoded statistically in the data.
So even though the models go through alignment processes like RLHF or constitutional AI, which try to make them fairer and less harmful,
Those alignment processes can mitigate the most egregious biases. They can steer the model away from explicitly toxic or discriminatory outputs, but they cannot fully erase the deep statistical patterns and correlations learned during that massive pre-training phase.
why not? Can't you just train the bias out?
It's incredibly difficult. Bias is often subtle, embedded in statistical correlations across billions of data points. For instance, if the training data historically contains far more examples of doctors being male and nurses being female, then even an aligned model, when asked to generate a story about a medical professional, might statistically be more likely to default to those gender stereotypes, simply because those patterns are so deeply ingrained in the data it learned from. It's reflecting the statistical reality of its input, even if that reality contains bias.
So the alignment might stop it from saying overtly sexist things, but the underlying statistical skew can still subtly influence its generations, its recommendations, its portrayal of different groups.
Exactly. It can manifest in subtle ways, the kinds of adjectives associated with different demographics, the default assumptions it makes, the examples it chooses to generate. It's an ongoing challenge to identify and counteract these inherited biases.
So understanding these limits, the finite context window, the very real risk of confident-sounding falsehoods or hallucinations, and the inherent statistical biases inherited from the training data. This understanding is absolutely non-negotiable for using these tools effectively and responsibly.
It transforms you from being just a passive user accepting the output into an active, critical collaborator. You become the guide, the fact-checker, the bias detector.
You're in charge, using the tool, not being used by it.
Precisely. And that brings us beautifully full circle back to our lawyer, Ali. Because now we can see his workflow not just as impressive, but as intelligently structured around these strengths and limitations. This is Section 5, Professional Synthesis, the Integrated Workflow.
Right. We can now really illustrate how Ollie stops being just a lawyer using AI and becomes, metaphorically, a lawyer with 4 superbrains, leveraging the distinct strengths we've identified.
His complex property case, remember, required several things. Broad creative thinking to find the best angle, then meticulous, careful language for the actual legal documents, then validation against the very latest up-to-date legal precedents, and finally, efficient production of the finished work product.
And the mistake many professionals make is trying to get one single AI tool, probably the one they know best, to do all of those things equally well.
Which it likely can't, right? Because of these different specializations we discussed, Ollie, being savvy, knows better. He orchestrates his digital team. Step 1, brainstorming arguments. He needs those creative angles, maybe some outside-the-box hypotheses that challenge conventional thinking about the case.
So for this initial expansive creative phase, he turns to
ChatGPT. Its strength in broad reasoning, synthesis, and generating diverse ideas makes it ideal for this.
Right. ChatGPT throws out 10, maybe 15 possible arguments, some conventional, some unexpected. It helps Ollie break free from any tunnel vision he might have developed under the pressure of the case. It generates the raw, conceptual material.
Exactly. Step 2, drafting careful language. Once Ollie reviews those ideas and pinpoints the most promising legal arguments, maybe combines a couple, he needs them translated into precise, non-speculative, professionally airtight legal language suitable for filing with the court.
This sounds like a job for
Claude. Given its constitutional AI background, its focus on careful, meticulous output, its strength in nuanced professional communication, it's the ideal tool for drafting those sensitive passages, the core arguments in a motion, or the delicate phrasing in a settlement offer.
minimizing ambiguity, reducing the risk of unintended interpretations, getting the tone just right for formal legal context.
Precisely. Claude helps ensure the language itself doesn't create new problems.
Okay, argument brainstormed with ChatGPT, language refined with Claude. What's next?
Step 3, checking live sources. Before finalizing anything, Ollie absolutely must ensure his arguments, however well-worded, are based on the absolute latest legal landscape. He can't rely on knowledge that might be months or even just weeks old.
So he needs that real-time check for recent rulings, new legislation, any relevant updates.
Crucial, and for this, he uses Gemini.
Leveraging its connection to real-time information via Google search.
Exactly. Gemini acts as the verification layer, checking if the case law cited by Claude is still valid. Is any new statutes affect the argument? Ensuring the entire strategy isn't built on outdated foundations. It brings that essential external current validation.
Okay, brainstormed, drafted, verified against current data. What's the final step?
Step 4. Final formatting and execution. The arguments are sound, the language is precise, the data is current. Now, Ollie needs to assemble everything into the final, comprehensive case summary or brief, properly formatted, maybe incorporating exhibits ready for submission.
And this is where the integration specialist comes in.
This is where Copilot shines, because it lives inside Microsoft Word or his firm's case management software.
Right.
Copilot can take that synthesized, vetted content from the other models, or Ollie's own final edits, and handle the often tedious tasks of document assembly. It can automatically format sections according to court rules, generate tables of contents, integrate citations, ensure consistency, all directly within the document environment.
So it handles the final mile, the practical execution, allowing Ollie to focus his final review on the core legal strategy and substance, not on fighting with margins and formatting.
That's the ideal workflow integration. It takes the high-level intellectual output and translates it into the required professional output format seamlessly.
That synergistic process, ChatGPT for ideas, Claude for wording, Gemini for current facts, Copilot for execution, that is a whole different level of using AI.
It really is. It's moving from using an AI tool to strategically orchestrating an entire team of specialized digital experts, each playing to their strengths, handing off tasks intelligently. That's AI mastery in practice.
And importantly, that orchestration is only possible because Ollie understands their internal workings, their training differences, their inherent strengths, and their limitations, the very things we've unpacked today.
Exactly right. So as we wrap up this deep dive, let's crystallize the 3 essential takeaways that we've distilled from this analysis of the modern AI mind.
Okay, takeaway number 1.
The first, and maybe the most fundamental, AI predicts patterns, which feels like reasoning, but it doesn't think like humans. Understanding that it's a probabilistic pattern-matching system, not a conscious entity, is key to using it wisely.
Remembering that n-squared computational method underneath the seemingly intelligent output, it's statistics, incredibly advanced statistics, but statistics nonetheless.
Precisely. Takeaway number 2. Each platform has a distinct personality and strength profile, and mastery comes from knowing which one to use when. Don't treat them as interchangeable.
Right. Leverage the creative flair of ChatGPT, the meticulous caution of Claude, the real-time awareness and multimodal capabilities of Gemini, or the deep workflow integration of Copilot. Strategic selection is crucial for efficiency and effectiveness.
Couldn't say it better. And the final takeaway, the one that really safeguards the whole process. Understanding AI's limits is just as important, if not more so, than knowing its strengths.
You absolutely have to be vigilant about those limitations. Keep the finite context window in mind for long tasks. Always be skeptical and ready to verify because of the potential for high-confidence hallucinations. And remain aware of the inherent biases inherited from the training data, actively looking for and correcting them.
Those 3 points really encapsulate the core understanding needed. Today, we set out to open the black box of modern AI. And I think we found not some unknowable magic or mystery.
No found method.
Exactly. A powerful, sophisticated method built fundamentally on the parallel processing power of the transformer architecture, guided and refined by different philosophies of alignment like RLHF and constitutional AI, resulting in distinct capabilities and personalities.
And perhaps the most empowering part of finding method instead of mystery is the realization that follows. Since we understand, at least conceptually, how these AI systems think, how they process information, where they excel, where they fall short.
That understanding gives you, the user, the power.
The power to guide them more effectively, to challenge their outputs critically, and ultimately to collaborate with them in a much more informed and potent way. Your understanding of their internal logic transforms you from just a passenger along for the ride
Into the conductor of your own digital super orchestra.